In chapter 5.7, we're going to talk about this man, Carl Friedrich Gauss, the guy to my left with the sweet hat and the mustache. He developed the fundamental theorem of algebra, which seems pretty important if it's the fundamental theorem of algebra, or as he called it, the Fundamentalsatz der Algebra. Fundamentalsatz der Algebra. And what he said was basically, with this theorem, that if a polynomial has a degree of 3, 4, 5, 9, etc., etc., what I mean to say, if it's x cubed, or x to the 4th, or x to the 5th, or x to the 9th, let's say it's x cubed, then it has that many zeros or solutions. So if it's x cubed, it has 3 solutions. If it's x to the 4th, it has 4 solutions, and so on. Now, he did say that some of these solutions might repeat. Let's say you factored out this equation, and you got x minus 3, or x plus 3, x minus 4, and x minus 4. Now, there are still 3 answers. The answers are, of course, the zeros are negative 3, 4, and 4. It still has 3 answers. However, one of them repeats. This 4 repeats. It still agrees with the fundamental theorem of algebra because it has 3 answers. Another thing that can happen, let's say you have an x cubed function. Maybe 2 of those zeros are actually imaginary. However, there are always 3. A mixture of real and imaginary answers will always lead up to the amount of answers it should have, the highest exponent in that function, so in that polynomial.
Alright, we're going to get to a problem that says find all zeros of the following function, and we're actually going to use our calculator here to save us a little bit of time. So in order to find all zeros of a function, remember, you can factor if possible, but when these start getting longer, it gets harder. However, we already know this is going to have 4 zeros because the highest power is 4. Okay? So the first thing we're going to do is we're going to list out the possible zeros like we have been doing. Remember, the factors of 7 are plus minus 7, plus minus 1, and the factors of the leading term are 1, so plus minus 1. Then we'll put those together, and we'll say the possible factors are plus minus 7 over 1, and plus minus 1 over 1. We'll simplify that to plus minus 7 and plus minus 1. So those are the possible rational zeros. Remember, rational zeros are the ones that are like integers or whole numbers. Then there might be some zeros that are irrational, that'll be like square roots. There might be some imaginary zeros as well. So let's go ahead and graph this one. I've already typed it in to save some time. We'll graph it. And it looks like this polynomial, we might have to zoom out a little bit to get a better picture here. So zoom out. Yeah, it looks like this one, I'm going to zoom back in, but it looks like this one only crosses, oops. It looks like this one only crosses the x-axis twice. That means that even though it's x to the 4th, this polynomial has 2 real zeros and 2 imaginary zeros. And we can use the calculator to help us get an idea of what the real zeros are. Since we've already listed the possible rational zeros, plus minus 7, plus minus 1, we can just look at this graph and tell that the 2 real zeros are negative 1 and negative 7. So we know the 2 real zeros are negative 1 and negative 7. We're going to write that back into factor form and say that as factors, those were listed as x plus 1 and x plus 7. Now, we need to multiply that back together to get x squared plus 7x plus 1x is plus 8x plus 7. So this is one factor of the equation y equals x to the 4th plus 8x cubed plus 8x squared plus 8x plus 7. In order to find what the 2 imaginary zeros are, we need to use long division using x squared plus 8x plus 7 and divide this by the original equation, x to the 4th plus 8x cubed plus 8x squared plus 8x plus 7. And that'll tell us what's remaining now that we've already taken out those 2 zeros that we know about, the minus 1, the negative 7, we're going to use long division here to find out what's remaining in this equation. So we'll go through this really quick. X squared goes into x to the fourth, x squared times x to the fourth plus 8x cubed plus 7x squared. This first one's working out really nicely. All those things cancel except for this last one. We're left with x squared. X squared goes into x squared. Looks like that'll go in there just one time. So we get to skip something here and go all the way to 1. So 1 times x squared is x squared. 1 times 8x is 8x. And then 1 times 7, 7. So we'll go ahead and subtract that. And everything's going to cancel here. And we're just going to get 0. So the final equation is x squared plus 1. And we're going to solve x squared plus 1 to get those last zeros. So set that equal to 0 and solve. This one doesn't require any factoring or anything. Sometimes this will require the quadratic formula, but here we don't need to. We can solve this a lot easier. X squared equals -1, and x is equal to plus or minus square root of -1, which is plus or minus I. So the 4 zeros of this equation were -7, -1, I, and -I. The last type of question in Math Excel and Quest will say something like, find a polynomial function of lowest degree with rational coefficients that has the given numbers as some of its zeros. So it's telling you that -2i and 8 are some of the zeros. Whenever you see a -i, you always know that you always have the positive version as well, because imaginary numbers show up in pairs, because they come from taking the square root, and when you take the square root, you get 2 answers, the positive answer and the negative answer. So i's show up in pairs, and square roots also show up in pairs. They try to trick you by only giving you like half the factors here, by only telling you -2i, but you need to know that 2i is also a factor. So we'll just go back and write those factors out. X minus 8, x plus 2i, and x minus 2i. These are the 3 factors that we know about. And now we just have to go back and, FOIL all these out to figure out what the original equation was. So x times x is x squared. I'm going to start with this one over here just because I really hate imaginary numbers, so it'd be great to get those out of the way now. So x squared minus 2ix plus 2ix, perfect that they're going to cancel out, and this will always happen. And then plus 2i times -2i, that's -4i squared. So those will cancel out, and we have x squared, and then -4i squared is just positive 4. And we'll go through and multiply x minus 8 by that to get x cubed plus 4x minus 8x squared minus 32, and put that in standard form with decreasing exponents, x cubed minus 8x squared plus 4x minus 32, and that's going to be your answer. We found a polynomial function with these zeros.